This is new. We're talking about chapter 6.5, angle relationships in circles. The three theorems that we're going to be talking about are on page 212, on the box at the top of page 212. The first theorem that we're talking about is 6.13. And like I said before, I could care less about that number. That means nothing. What I want you to understand is the information that's contained in the theorem. Alright, so here we go. The first theorem says, if you have a tangent and you have a chord, then there is a relationship between this angle, x, from here to here, and the arc from A all the way down here to C. And the relationship is the same as an inscribed arc. So the relationship is half as big. If this one is 80, if that angle measurement is 80, then that arc in bold here would be 160. It is half as big as that arc. Okay? That taken by itself is not that difficult. But when you tie it into the whole circle, it can get a little harder.
Can you go
Okay. Here's this angle right here, 80 degrees. Okay, it's made up of the tangent and the chord. The angle, 80 degrees, relates to this arc that it makes from this point of tangency up here to where the chord ends. That arc there is 160 degrees. Double the amount of the angle. If the angle is 80, then the arc is 160. Hold on, let's do the other side. If this angle here is 80, I know the total from there to there is how much? 180. So if this angle here is 80, then this angle over here has to be the supplement of that. It has to be 100 degrees. So if this angle here is 100 degrees, what is the measurement of arc ABC going to be? What is the measurement of the major arc ABC? 200. Very good. 200.
So no matter what number is there,
it has the exact same relationship as an inscribed angle, which we did yesterday.
Any chord, they give you
A tangent and a chord, that's the relationship. Okay? Now, how are they going to make this problem more difficult? I'm sorry if you were still writing. How are they going to make this problem more difficult is they're going to do this. They're going to put a tangent and they're going to put a chord. And they're going to say that this angle here is 70 degrees. And they're going to say find x. Yeah, that's right. What you might be tempted to say is what? 140, right? If that angle is 70, then this arc from here to here is 140, double the amount. However, that's not the angle or the arc that we're looking for. We're looking for this one over here, and we have two ways of getting it. We could either say 360 minus 140 is 220, right? 220. Or we could figure out that this one over here is 110, and we could double it. Either way, we should get 220 as our final answer. Questions? So any questions on this theorem? You got a tangent and you got a chord. The relationship between the angle and the arc is that the angle is half as big as the arc. Okay? Questions? All right, let's try 6.14. Let's move to the next theorem.
And you have to have a tangent.
In order for that theorem to work, it has to be a tangent. So here we go, 6.14. In 6.14, it's talking about two chords. Two chords that intersect inside the circle. Very important is that they don't intersect at the center point. Before, we might have had two chords that intersected, and they intersected at the center of the circle, giving us a central angle. The relationship between central angle and arc was that they were exactly the same. So now we're talking about two chords that don't necessarily intersect at the center of the circle. Okay, the center is here somewhere. Okay, the relationship between this arc from here to here, 90 degrees, I'm just giving you an example, and this arc here, which would be a little smaller, let's say 50 degrees, and this angle in the middle, x. Two chords intercept somewhere in the center of the circle. They create two arcs. They create a big arc and a little arc. If the arcs are the same, then they intersect at the center of the circle. the way that we find x, just what it says here in the theorem, is 1/2 the sum of the measures of the two arcs. Well, 1/2 the sum is simply the average. 90 plus 50 divided by 2. What's 90 plus 50? 140 divided by 2 is 70. Now watch this, it's very important. That means that that angle there is 70 degrees. It is the average of the two numbers. That means that this angle is now 70 degrees. Right? Both of those angles are 70 degrees. How? Because they make those arcs. 90 and 50 average to 70. What is this angle here and here have to be? Has to be the same. What is it? 110. How'd you get that? What's the right word? Geometry starts with an S. They're supplementary. Right? 70 and 110 have to add to 180. So they're supplementary. Okay? Questions? Now there's two other type problems that they're going to give you. There's lots of different types. There's two main more examples that I want to show you. Are you ready? Everybody got this? Any questions? Yes.
So, on this, we didn't have anywhere that asks, well, what would be the other two arcs?
Well, we're getting there. You're right. We're getting there. Okay? Anybody else have a question? Yes.
Are they going to always give you like the 90 and 50 arcs?
Nope. We're getting there. Y'all are on the right track. Y'all are asking the right questions. We're getting there. So here's a circle, and now here's two chords. I'm going to say 100 and I'm going to say 80, and instead of the angle that I want, now where's my variable? It's in the wrong spot, right? That's not the angle that I find. When I average 180, what do I get? What's exactly in the middle of 180? 90. 90 is in the middle of those two numbers. It's the average. However, if that one's 90, then what does x have to be? It just happens to be 90. But that's a common problem, is to put the x in the wrong spot. And if you're not paying attention, then you'll get the problem wrong. It just happened to work out in this one that they were the same. Okay? Questions? Any questions? Let's do it again and say 110. Now let's do it. What's the average of 110 and 80? 95. So if this one is 95, what is x got to be? 85. See the difference? You'll put 95 and get it wrong when 85 is what they're asking for. So you have to really pay attention. This angle and this angle are the two angles you find when you take the average of these two numbers. Okay?
Can't you just find...
Yes, you can. Yes, you can. Hey, you're very good. We're almost there. Corey, you good?
Yeah.
All right, here we go. Last example. Instead of giving you the two arcs and asking you to find the angle, they're going to say 45 and they're going to say 60 and they're going to say find x. And what, Tanner, go ahead and say what you're going to say.
I was going to say just go around in a circle, because you could take 180 minus 45 and get that angle arc.
This arc over here.
And then you could take that minus that minus...
The only problem with that is this is not necessarily a semicircle. It doesn't, the center might be here. And if that's true, then it's not a semicircle.
Well, then you just take...
You're on the right track. How are we going to find x? How are we going to find x? Let me show you what the book wants you to do. What the book wants you to do is they want you to say x plus 45 divided by 2 is equal to 60 and solve. You have to multiply by 2 and subtract 45. Well, what is a much easier shortcut in order to do this problem? Anybody? No? All right. How far did you go up from here to here? You went up 15. If this is the average of these two numbers, how much are you going to have to go up from there to there? 15 more, so what is x equal? 75. See how easy it was? You like that shortcut? Okay, you want to do it again? Alright, I'm going to keep that 60 in the middle, and this time I'm going to say 90. If I had 90 here and 60 in the middle, then what would x be? How did I go down to 30?
90 minus
I went down 30. I better go down 30 some more in order to find that other side. It's a shortcut. It works every single time. Okay? It's a shortcut and it works every single time.